So today we'll be talking about the quick overview for MONAI Deploy. I'm Barbara Selnur Erdal. I'm an associate professor at Mayo Clinic. Uh, and with me, I also have Dr. Vikash Gupta, who's also assistant professor at Mayo Clinic. And today we'll be talking about MONAI Deploy. So let me do the introduction and I'll pass the baton on to Vikash. So if we look at the traditional clinical workflows, like this is not comprehensive. What we're showing here is more of a collection of average of events that are happening within our participating institutions. So if we were to assume a traditional clinical workflow, it would start with an order from a ordering physician for an imaging study, and that would create like a what we call an order for an exam. Let's say you have questions about a lung cancer patient and you're ordering a CT exam. That would create what we call an order in the system. And that order will be recorded in the EHR, EMR to be acted on. Based on that order, then you would be scheduling a patient. That patient will be scheduled for a scan for this example, let's say for a CT scanner. And once the patient is scanned, then the images will be distributed across different endpoints. One of them would be like a DICOM router. That router would send your images to a storage and a potential view for clinicians to take a look at, and also a workstation for radiologists. Along the way, radiologists, even though radiologists would receive this image on their workstation, they wouldn't know which one to read in which order. At the same time, the EMR would populate what we call a work list. And on that work list, then radiologists would know which images to look for on their daily workflow. In this example, we used a lung cancer screening or follow-up. That would be like a chest radiologist, maybe looking at those images. Then once the images are read, on those images, you would write the report, and that report will go back into the EMR to be viewed by the physician who ordered the exam. So what I described here, I tried to make it as short as possible, was a somewhat of traditional imaging workflow. And within this workflow, there are certain places you can utilize AI to aid or different components of this workflow. So in traditional systems today, in most hospitals in the US, there is what we call a clinical decision support system in the ordering phase. So everything starts with an order, like what we call the HL7 order is created. But that order creation by the physician is guided by, in the US at least, ACR, American College of Radiology's appropriateness criteria, and physicians are making those decisions based on, let's say, here's the reason for this exam, lung cancer, or let's say breast imaging, patient is female, is above 40, what is the most appropriate exam? That decision process is what triggers the whole event. And the whole loop is closed by when the images are scanned and the reports are returned back to the EMR regarding what's happening in regards to this patient. So the reason I cover that, if you look into the traditional radiology workflows, will be, as MONAI Deploy right now, our current focus, at least for today, is everything in between the order creation and the report generation. So we won't be covering decision support systems. AI goes in that space, like how to order the best exam, or there are other down the line algorithms such as what is the best slot to schedule a patient to on a given scanner or time zone. This is not what we're covering. We're more in the pixel space, or we're not covering what report should look like. And there are AI, like natural language processing based AI or voice recognition software that handles that. We are not covering that space. What we'll be covering is in between the scanner on this diagram and what goes into a radiologist workstation. That's more aids, like let's say you do a segmentation algorithm, your image detecting sound classification algorithm, where that's where those are happening. And as a result of those, you might be triggering like what we called a work list earlier to say, hey, can you read this image first because I have a finding here? Or you segmented some organs, just like the previous example, to speed up the next steps for the another algorithm or the physician themselves. It's segmented, volumes are calculated, whatnot. So I just want to give like a broader picture for awareness, because even though we're covering for those what we call pixel spaces, at the end of an algorithm as a result, you quite often your algorithm has to integrate with non-pixel spaces, meaning you may need to send like as a result of your algorithm to play in this area, you may need to create your incoming study might be like a DICOM series, but you might be producing a result in DICOM SR to trigger like a voice recognition software, or an HL7 message to trigger like a worklist item so your image can be seen and the reader knows that you have an AI finding they need to pay attention to and they need to act upon. So with that in mind, I'm going to move to next. So what we are talking within that current within the current scope, it's as MONAI is always like evolving. We're adding more and more items that we are working on. But within this current app SDK that we'll be talking about, we'll be talking about how to deploy, how to how to take your algorithm and deploy it into a platform like this so it can execute. It can function within the standards of the current like medical realms. And to do that, we will be showing how to take a algorithm, wrap it into what we call a map. It's a MONAI application package, and deploy it. And once it's executed, what the final product looks like. Of the final product, what we mean is what can be consumed by the systems which we are kind of defining in this like first phase. With this, I'm going to pass the baton to my colleague, Dr. Vikash Gupta. Vikash, do you want to take over like the presentation?
Yes. Hello, everyone. Can you hear me fine?
I'll start
sharing.
sharing.
We can hear you,
Vikash, you can
Vikash.
share now.
Yeah, okay. So, all right. So, first of all, thank you, everyone. And thanks, Tom and Selnur, for the nice introduction and makes my job certainly easier. So, let me go over this. So, I'll talk. So, you have seen how Tom deployed an amazing total segmentator application using MONAI application packages. And what Dr. Erdal told you about is like how maps are relevant in the hospital infrastructure. And so now that you know what all can be done, I am going to delve a little bit deeper and show you some of the capabilities of maps. And also, I will try to show some of the code. And so when you go back and like look at the GitHub, you know where to look and what to find. I mean, like how to build your own maps. It will make your job a little bit easier. So that being said, um, let me go to the next screen. Okay. So what is a MONAI application package or map? So it is a self-contained, reproducible, portable, production-ready AI inference application. I mean, that's certainly a mouthful, but what I mean is that in a map, you can encapsulate it such that it contains the model, it contains all the necessary code that you need to run that model. It also contains, and it is, you can package it as a Docker image, so you can run it anywhere. And it has these hooks that can plug into the existing hospital infrastructure. And that is what is one of the most amazing things about it, because then you can just build the map and you can deploy it wherever you want. So that's what leads me to the next slide, which is called Map Once Run Anywhere, monikered by David in the MONAI Deploy SDK group. He says, it has a lot of other capabilities also. First of all, it's Pythonic, and so it's easier to develop. It has DICOM integration capabilities, and it also has DICOM study parsing, and all these capabilities make it very suitable for clinical deployments. And um, and uh, and it has a very strong community support. As you can see, like today we have 100 people in this meeting, and we often have like these kind of boot camps. So you can start learning whenever you like, and new features and issues get resolved on a weekly basis. So we really pay attention to what people are asking and if they're running into issues. So it's a very alive community, and that's why if you need any help, there are people who will very knowledgeable, who will come and help you and resolve your issues. So this is taken from the MONAI Deploy App SDK website. It is what's the architecture diagram. So it has two components. There's the development time and there is the runtime. During the development time, you create the application making use of graphs which contains operators. So this kind of sound again like a mouthful, but it will become really clear that how can you chain in operators in a graph to make an application and then run that application in runtime and also package it use and all under this MONAI deploy framework. And we will see all of that later. So I just wanted to give you a side, like there's a development time and run time in which you create application, and there's an app packager which can run it. So that being said, what are the components of map? So you will hear these three terms quite often. One is operator, the second is application and DAGs. So operator is an object that performs a unit operation. It has an input and output port. It takes the input data, does something, and sends it to the output data. Okay. And these operators do not really need to do anything specifically AI or deep learning. They are just operators. They can do anything. They can just do like addition. That's the thing. And then you have a bunch of these operators. They are chained together to form an application. And the chaining happens in a directed acyclic graph fashion, so that our output of one is fed into the next one and they are chained, and that's what the anatomy of a map looks like. So yeah, that being said, as you can see here, there is DICOM. So this is a typical clinical deployment scenario in which on one end you have DICOM receivers, DICOM operators, and everything to do with clinical data. And I'm talking in terms of radiology, in the context of radiology. And then on the output, as Dr. Erdal just mentioned, you could have DICOM SR, DICOM SEG for segmentation objects or any even text-based things. So starting from the left, you have a DICOM receiver, which receives DICOM images from anywhere. And it could be sent to this application using a DCM TK tool, like DCM send, or could be sent from a PAX, or could be sent from anywhere. There is a DICOM receiver at that end. So a study is received, and there are again DICOM operators which will parse the study, extract the relevant series that is required. And then there are pre-processing operators. I mean, this is an optional operator. So to give an example, like if you're working on brain imaging, there are certain pre-processing things that you need to do, like, for example, skull stripping or N4 bias intensity normalization correction or resampling of the images. So all this forms in the pre-processing step. And then comes the deep learning part where you have the actual models for segmentation or classification, and then they will give you the output. And then you could have some post-processing stuff that can be done. Like, for example, let's say you segmented a tumor, you want to see what's the volume of the tumor. It could be a pixel counting or some sort of post-processing step, or you got the uh, classification and you want to save it as a DICOM structured report. So these all are post-processing steps, and everything has the same structure. It is an operator and they need to be linked. So let's say you receive a new brain imaging, and it has a series selector. So it selected the T1 image. It has a pre-processing. It did the skull stripping, and then it did a bias intensity bias correction. Then it segmented the tumor, and then you counted the pixel on the tumor and you saved it as JSON. And also you wanted to classify the different like different types of tumor. You can also save this, and they can chain all this together, and that's how a map looks like. And please feel free to interrupt. Actually, don't interrupt, because I won't be able to see the questions, so I'll answer the questions later. Thank you. So yeah, flexibility of a map. So the IO can be anything. I showed a DICOM example, which is a clinical setting, but ideally it could be anything. It could be a NumPy array, JPEG, or whatever. And the operators are flexible and they can incorporate different algorithms, and operators can be permuted in any permissible manner. And I'll explain what permissible means in this case. And you will see that the application package can run locally on a cloud, Pythonically. You can do a Docker-based distribution, and future compatibility with other components of MONAI, like MONAI bundles and MONAI Deploy Express, is kind of ensured because it's all under the same flag. So those are the flexibilities of a map. And that being said, I like to give an analogy of map in the terms of a NASA's space shuttle program. See, so like it's like you have the space shuttle, and any new technology that comes in should retrofit to the existing technology and should also be future proof. So what maps does is sort of takes care of that. Like it you can deploy it in a clinic which has like 10-year-old technologies right now, but it is also future proof in terms of cloud based developments, which JP from AWS would show later on in the slide. So it is kind of flexible. Like it can it can, you can retrofit, and also there is some sort of some level of future proofness to this as well. So that being said, I've been talking a lot about different qualities of map, but let's have some look at the code. And yeah, so here is the first atomic example, which is the MONAI operator, which I was talking about. So this is a very simple example where you will see there's a Gaussian operator. It does nothing. It takes an image and applies a Gaussian filter to it and writes the output. So as you can see, there is this native function where called compute, where everything happens. And for most part, these are some boilerplate code that you need to write, and you will learn as it goes. Like here with MD, which is the MONAI deploy core, you define the image and the data type. IO type is in memory, IO type is .disk. In memory as in like you're receiving something, IO type .disk means that you're writing it out on a disk. And these explanations are available on MONAI docs. So you see here, it receives like line 31, it receives the input and gets the NumPy array out of it, applies the Gaussian filter, which is from scikit image. It applies the Gaussian filter. It generates the output folder, which is given, and then saves the image there. So it's a very simple operator. You do it all the time, but again, it can be done in maps. So map is not just much anything related to deep learning and models. You can do operations in it as well. Similarly, let's look at another example, like how these operators are chained. So in this example, you see there are similar, you saw the Gaussian operator. Okay, there is again Sobel operator, median operator, and whatnot. And you can, and all these operators look the same. Exactly. You just change the function on line 32. So you see this, what I was talking about, direct acyclic graph. So this graph thing happening here. So here we are composing the operators. So what is happening is you receive your image, it goes to a Sobel operator, the output goes to median operator, and then it goes to Gaussian operator. And then you have the flow, this self.add flow. The input from Sobel goes to median, from output from median goes to Gaussian operator, and that is the application, right? And then I was talking about running an app. So there are various ways to run an application. So you can see it can run it Pythonically, which is self-explanatory. And then there is MONAI Deploy provides a CLI, command line interface, to run it. You can run it using MONAI Deploy exec my app. Input is some image, output, and with the model. Also, MONAI Deploy package is a CLI that creates a Docker package, Docker image out of your map. So it looks at all the dependencies and builds a Docker image. So you just provide what's the base image would be, what's the name of the output image, here in case my app, you apply a tag latest, and which model you are providing. You just provide all these things and it will make a Docker image that you can see in your Docker repository. And then you can just run this Docker image, and that's what makes it portable. So I will stop for a moment here. Like, and Michael, are there any questions for me to answer?
There is, David answered one of them, but if you wanted to expand or talk about it, is what format must a model be when included into a map? Torch script, is there any other specifications for what can actually go into it? And you've kind of been expanding on that it's not even just models, that you can kind of do a little bit of everything, but if you wanted to mention any other things around that.
Yeah, so that's a great question, because though MONAI is PyTorch compatible, but in this case, you can use a torch script. You can use, I think you can use TensorFlow as well. You can use direct PyTorch models as well, and I will show you. Okay, so it's not limited to torch script. I'm just showing here because I had this example, but
Yeah.
Anything else?
And yeah, one more actually just came in. So it says, is it possible to run the map with an input trigger, meaning the model predicts segmentations only when new studies are added to the packs? Currently, it seems to work only on fixed input and output directories.
So it's possible, and I will again show the demo. And the triggering mechanism is something that you need to design the logic on. Like, is it like triggering the map based on when the image comes in? Is it an event-based trigger? And all those things are more like orchestrator. But you can choose how to trigger it. And I will show you one example of it during my demo. Okay.
Cool.
Okay. So now it comes to like how to look for information. So of course there is GitHub, and there is a documentation page, and on GitHub, feel free to ask questions. As we said, like, we resolve issues on a weekly basis. And there is a folder. Let me reshare my slide because I want to show you something. So I guess I'm doing well on time. Yeah.
Yeah. I think you have at least another 30, 40 minutes.
Okay. Awesome. So yeah, first thing first is I go to GitHub, MONAI, okay, just MONAI Deploy App SDK. So yeah, like there is the GitHub. right? And you have like getting started, and here you have bunch of tutorials and explanations where you can see what can you do. You can also contribute, and there is no documentation is good enough, but we try to do as good a job as possible. So if again you run into problems, ask questions, we'll be happy to answer. And then there are all these modules and explanations are written here. As you can see, there are a bunch of operators already in there. You have DICOM data loader operator. You have MONAI bundle. Now you might have heard about MONAI bundle. So we have already integrated that into it. So there is a MONAI bundle inference operator. There's a Nifty data loader for someone who wants to work with Nifty images and not work with DICOM. So all these things are there. Have a look, and based on this, you can write your own operators as well. So that is this place. And then again, a better thing would be just going to GitHub. I'll show you some more stuff. MONAI App SDK. Yeah. So yeah, here's the code. And mostly if you go to notebook tutorials, you have examples which have been here since last year and since it started. And you can see this new examples pop in, and there is a proper documentation over here, and you would be able to, along with the example images, you should be able to run it. There is notebook tutorials, and there is also example applications, so many of them. And if you can, whatever you need, you can mix and match between these examples, and I'm sure you can find a solution. Okay. So and again, if you get stuck, please do ask. Okay. And that being said, let me just share my screen one more time. And so yeah, so I talked to you about how to look for information. Um, at this point of time, I'll quickly show you a small demo, and you can still see my screen. Yes.
Yeah, we can see it.
Okay. Awesome. So let me just try to show, like, I won't do any live coding, but I will like run through some code so you can get uh, a sense of what I'm talking about. So okay, so I have not run this code, but okay. So again, this is example code to just load a JPEG image. There is nothing too crazy. You have this boilerplate imports, which you will do. And this is a very simple function, like load a JPEG image, and you have the input context from disk because you are reading from disk and you want to save it on the memory. So you see, you just define those input outputs, and I just over engineered this small solution just to show some of the things. So like you have this main function that the operator looks for, is called compute. And then if you have some complicated data and you want to load it in certain way, I use here PIL, but you can use OpenCV or anything. And then it just loads the image and puts it into your memory to do whatever you want. So what I'm trying to say, that whenever you hear maps, you can, if you have an old application, also not necessarily deep learning related, you can still use it. No worries. Let me see if it works actually. So we see, I have not, oh yeah, it works. So it's great. But let me just show you something more. So yeah, this is another example I built just to mess around. Like you can do a lot of other things. So for example, this is again load PIL operator, like simple load image, send it to memory. And then there is this dummy operator, which just like reads the image and then sums all the pixel. So you can think like, there's a tumor and there's a tumor mask and it wants to count how many pixels there are. So it just counts all the pixels and gives you an output. And that is your operator. And then you have a result operator, which is towards the right part of that graph that I showed. So, so you can think of it as your like image loader. You load an image, simple JPEG image, and it has some segmentation. So you did some segmentation and you counted all the pixels are. So this is your post processing, if you may. And as you can see, like, I'm not constrained to only MONAI data types. I'm using ND arrays, NP, NumPy, NumPy arrays, floating point, whatever data type you want. It doesn't have to be restricted to like a MONAI image type or something like that. So in that sense, that's the flexibility that the map offers. It's not restricted. So here I mixed, here there is a scalar, and it is output is a MONAI data type called data path. So again, and now all these things, and I am compiling all. So I defined all the operators, like here's my fill operator, here's my dummy operator, result operator. I am composing it. Fill operator, receive the input in the fill operator, send it to dummy operator where it counts, and then write the result in the text here. So that's like, it's very simple. Read, do something, write. Okay. And here is the main test function for this image, and I will run it. And I'll show you something like I'm running it Pythonically, app.py. So yeah, you see here, it generates all the logs. So you have executing this operator. That's all in the good. It helps you in debugging. So right now it load PIL operator. It loads the image, and then it does dummy operator, just does the pixel counting, and everything has a process ID, and it writes the result. And you see my input is here, and then in the output there is the result.txt. It counted all the pixels that was there, it summed, and there's the result. Is there any questions at this point, Michael?
Not yet. Nothing else has come in that hasn't been answered already.
So yeah, that's like a very simple example to show, to convince you that you don't have to think only in terms of deep learning. Now let's get back to more complicated stuff now that we talked about it. Okay, so we're going to talk about this so you saw a segmentation example by Tom. And as you know, like in most of the problems in radiology, either it is a segmentation or classification or detection. So I'm going to show you a classification example. And I hope like a lot of you know about breast density, but this problem is not important. The execution of this is important. So to give certain context, like breast is given like 4 categories depending on BI-RADS. That is, it can be entirely fatty to extremely dense, A, B, C, D. And it's a routine evaluation that the radiologists need to do on every mammogram that is acquired. So we, by the way, this model is available on MONAI, and you are free to download in MONAI Model Zoo. It is also available in the form of a map, so you can take it and use it along with some examples. So, and play around with it and try to break it and make new models out of it. So this model is again based on a transfer learning from Inception v3, and the proposition is of this model was that most deep learning models are based on mammography, but this model was based on mammography as well as tomosynthesis data. And we saw that this model performs quite good on all kinds of mammography, tomosynthesis, and C-view data. And the accuracies are pretty good, above 90% in almost for all the groups A, B, C, D. Again, this is not the main focus of this presentation. The focus is how it is deployed. So yeah, these are some results. As you can see, it classified group A, group B, and you see that it gives the probabilities for all the four breast types. And group C, here you can see the highest probabilities for group C, so it's group C, and group D as well. So these are some of the output. And this model, as I said, was developed at Mayo Clinic in our lab, and is available for download for free. Of course, it's an open source effort. So in MONAI Model Zoo, as well as a map is available, which you can download and see. And I will show you how to answer the previous question, which was like triggering of these applications, like how it is deployed on premise. Okay. While I'm changing, is there any questions, Michael?
Yeah, there was that one came in, and it actually might kind of be answered by when you start going through this, but the question is, do maps always have to run completely on the same node, or can they also be distributed across multiple nodes in a cluster? For us, it would be super useful if some operators could define specific resource constraints, higher RAM, GPU, etc.
So as far as now, as of now, all the examples that we have, it runs on the same node. But I could think that you have the graph, right? And let's say you have certain processes that need to be executed on one node, and the result is need to be sent on the other. So let's say like you want the tumor segmentation to happen on one powerful node, right? But the pixel counting needs to happen on something else. So yeah, I can imagine like, you create the map which does this tumor segmentation, creates this DICOM seg, which is your DICOM seg object, and just send the DICOM seg to another node which can do the pixel counting, and then send it to the output, rather than, so you can dissect the map based on the nodes, I feel.
Yeah.
Okay.
And then
So
also I know that you guys have the decorator classes on top of each of the operators as well to dictate things like the amount of the GPU, the amount of VRAM, I think, all those sorts of things as well are included as options for sort of resource constraining as well.
Yeah. So, I mean, nowadays there are so many GPUs and, like so much memory, like it's not so much of a concern at this point. So I don't think of it now, but of course,
Yeah.
you can, yeah. So here is a breast density example, which is deployed on our premises. And I have kind of simulated the packs and the receiving of DICOM data and, execution of MONAI model. But and after that, this same model was deployed on AWS cloud, and JP from AWS would be able to answer that. So that kind of to show that how it is deployed on cloud. So let me show you here. So I have a start receiver, which is basically nothing but a store SCP DICOM receiver. It just receives DICOM images. So bash start receiver. So it's ready to receive any DICOM image, right? And here is Python process dot just process. And again, this is nothing but it's like when it receives the image, it triggers. So this is where here I'm okay. Sorry, this had to happen one time, right? Like yeah. So there is this map which is ready to receive to give do the model inferencing, right? And it just has to send. So like I have some images that are canned, just like one image that is here, and I will just send that image, right? I said like, okay, send this image. And on the receiver, you will see like immediately it will receive. It received the image, and as soon as it received, here you can see that this this MONAI has it's received waiting, and then DICOM data loader operator kicks in as soon as it receives. It loads the image, it selects the appropriate series, and then the classifier where the actual like model inferencing happened, and then there is SR writer. So it writes the DICOM SR image and it sends it back, and it says that it's done, and then it sends it back, and now it's waiting for another image, right? And Control Shift O, and I'll say like bash send another image, and it receives yes, and then it does the processing and goes back again. Okay, so that's kind of the idea. And this is the breast density application, and I can just quickly show you something that it's like, okay, so this is just the logic written here, and I'm trying to see the breast density app. So yeah, like app.py. So here you can see again, there are a bunch of operators which are in different files, and like, again, it's nothing, there's no magic. This is DICOM data loader, DICOM select the series to volume, and then you run the classification, write the SR, and each of these operators are already there in the example. So you can just take those operators and make your own application. It's not, it will be, and then it sends there as well as it writes in text file. So you can see like CD output. So this is the final output.dcm, which is the DICOM SR object image. And if I'm not wrong, I could actually one sec, let me just see breast density Vim app. So let's say yeah, if again, if you have questions, I'm happy to answer any questions or comments. But yeah, that's how you deploy this on-prem, and it works with the existing software, existing infrastructure. But again, the same model was deployed in AWS Health Lake, which is like super amazing and is not even out yet probably, but JP can talk about it. And that's the versatility of MAP is. And I'm happy to take any questions before handing over to JP.
Yeah, so see, one just came in. And again, if you guys have any questions, please put them in either Zoom chat or in Discord, either works. But let's see, this one right here said, how did you simulate the PACS with an Orthanc DICOM web server?
Yes, like there's like I use the term pack sometimes like very loosely, but what I meant is like there's a yes, you are right, absolutely, DICOM web server, Orthanc, that you're receiving.
Yeah. All right, I'll give it another minute, see if any other questions come in. Like you said, Vikash, there are those tutorials that are in the repo. I encourage people to go out and try those. We also have some recordings from previous events as well on our MONAI YouTube channel that has them. If you go through the MONAI Deploy documentation, there are also some videos within the documentation that walk you through different pieces of everything. If there's any particular piece that you want to know more about or you'd like videos about, it's always helpful to know what makes sense to what you guys are interested in learning more about, and how what we can do to kind of help your process of learning how to use MONAI Deploy. So if you have any suggestions, feel free to mention them to me, or you can always submit them on GitHub as well, of if there's anything that you're looking for additional resources.
And I'll just like to add one thing that we are thinking, but it's not yet in production. I think like make very small 2 to 3 minute videos about like how to make an operator. Like that's what we're thinking. And I don't know, when we get like enough bandwidth, we'll start making like very small videos so that you can like quickly see and know exactly where to go. So that's something that's in the process.
Yeah, I know I've been wanting to work on some of those for a while, but like you said, when we have the bandwidth to be able to do them and get them edited and everything. Someone was asking if you could elaborate more on Informatics Gateway and Workflow Manager, how they used, and talk about some of those other pieces in Deploy.
So I think like probably I'm not the best person to answer that, because I have used MONAI Deploy Express and it's amazing, but I don't know about all the pieces of that, to be honest. But I'm sure like if you ask in the discussions, or like there are better people who could answer that question for you.
Maybe I can help on that, Michael, by the way.
Sure.
So hi everyone, JP Leger from AWS. I've been participating in collaborating into the MONAI Deploy project. I've been working at writing code a bit for the MONAI Informatics Gateway and a bit for the Task Manager and Workflow Manager to integrate them into some of our AWS services. So to answer that question, the MONAI Informatics Gateway is the interoperability component of MONAI Deploy and MONAI Deploy Express. This is the part which receives the ICOM data and then prepare the data to be consumed by the Workflow Manager and the Task Manager, which will then decide which map should be actually processing the data which was received. When the map has actually finished the processing of the data, if the prediction result is a DICOM object, then the MONAI Informatics Gateway can be configured for the DICOM object resulting of the processing to be exported to a DICOM entity. So this is the role of the MONAI Informatics Gateway in MONAI Deploy. MONAI Workflow Manager is more about deciding which algorithm should process which type of data based on the preparation that MONAI Informatics Gateway does.
Great. Thank you, JP. Let's see. Another one just came in. Any special security or privacy protection features that make MONAI Deploy stand out?
I mean, I'm not a security expert, so I will refrain from answering those questions. But I think, and mostly, see, the thing is, I would like to know when people ask about security, like what it means, because it could mean a lot of things. Like on an on-prem system, it is already inside the hospital network. It's not leaving, and AWS is pretty secured. So and I'm sure, like I think Ming, who is also one of the who's the main developer of MONAI Deploy App SDK, he talked about security. So that thing is like concerns about security is already there in our mind, but I'm not the best person to answer that.
Yeah, I think like you said, Vikash, there are a bunch of different pieces to it. JP, I don't know if you're going to go into a little bit of that with health, like imaging and that sort of pieces. I mean, because again, there's a difference between on-prem and in the cloud, and what sort of maybe security concerns someone might have to think about when setting something like this up.
Yeah, I would think you can actually run MONAI into a self-contained EC2 instance. I will be covering that during the presentation. So an EC2 instance is nothing more than a virtual machine running into AWS, to simplify. So the challenge would be to bring the data, the DICOM data, which contain the PHI, securely from the site to MONAI Deploy. And as you may know, doing DICOM over TLS, secure DICOM is not necessarily trivial, and that's something that a lot of institutions on production are not going to do. So this is actually one of the challenges we can overcome with implementing health like imaging, as I will be presenting.
Yeah, cool. One other question for Vikash. They asked if they could find the example with the trigger that you showed in GitHub as a tutorial, or is there anywhere they can get that and kind of play with it around themselves?
Okay, so I no, in the tutorials there is no examples regarding the trigger, but and it's kind of by design, because we want people to take maps and use it, and not necessarily the triggering and receiving part is sort of informatics gateway, and how you can trigger it with a message or whatever. But I can tell you, like, how it's done is basically you have a folder which is a receiver folder, and you in that folder start a DICOM receiver, and then you send images to that DICOM receiver, and it is received in that folder. And my process.py file, it essentially just watches those folder for event changes. So as soon as there is a, and in Python there are like watchdog kind of features, right? And you can look for event changes, and as soon as there is a change in event, you trigger the let me, depending on how much time, do I have 2 minutes? I can show you.
Yeah, you can go ahead and show.
Yeah, because I mean, it's nothing really. Just let me just, where's the share button? Oh yeah, okay.
Yeah, and then I'm also going to put the MONAI Deploy Express link. I know it's a little bit, so it's in the MONAI Deploy repo kind of 2 levels down. So I'll put that in chat as well. And that way people can take a look at it if they're interested in some of the workflow manager, informatics gateway kind of infrastructure and other things that are set up in there. It's not quite this one that Vikash is showing, but to some of the other people who have asked about just what is informatics gateway, workflow manager, how is it used, how is it tied into the system, it kind of gives a nice single node example of what that might look like. So I'll put it in both Zoom and Discord here in a moment.
Yeah, I'll say MONAI Deploy Express is super easy to use. Victor Chang did an amazing job. So if you can download, and it runs out of the box, like, I could assure you that. So it's really amazing. I love it. And so you see here, like, it's nothing. It's just like a forever loop, and you have the application, and it's Pythonically you can run it. So here is your application that is packaged. You have the model, you have the processing and process directories, and 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 you see that you just run it. You just pass this run function in it, and you give the input and the output directory and the model, and it runs, and then it sends the DICOM away, and then cleans the directory. So it's really very very simple. Like yeah, there are these uh, like watchdog kind of Python libraries, and you can just string them together. So this was such a specific use case that we didn't put it into the this thing. Yeah. So and reach me out if you have questions. Like I can reply to you directly. No problem. Okay.
Yeah. Cool.
I will stop and I let JP take the lead now. Yeah.
Yeah. So thank you, Vikash and Selnur, for that presentation.